Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. This is basically a word problem, and you'll find this kind of problem in calculus. It's called a related rates problem, and I'll show you how it gets its name in a moment. But the problem is there's a spotlight down here on the ground, and it's shining on a person that's two meters tall. And so you can see the shadow is going to be here to here, and we're going to call that h as the height of the shadow. And you can see if this person, if the woman is closer to the spotlight, the shadow will be bigger because her head would be here, and the shadow is going to be much higher. And as she walks away from the spotlight, the shadow is going to become shorter and shorter. I think that's pretty clear from the diagram. And so we need a relationship between time, as time elapses as she's walking, and the height of her shadow. So that's why it's called related rates. We're interested in, we have two speeds, the speed at which she's walking and toward the wall, away from the spotlight, and the speed at which the height of the shadow is decreasing. So we know the speed it is 0.6 meters per second, and we have to find the rest of it. Okay, so we're going to make use of the fact that these are similar triangles here. They're both right triangles, and they're similar triangles. This distance here, I'm just going to call 0.6t, because that's how fast she's walking. So 0.6 meters per second times the time elapsed, t. And then this distance would be, of course, 16 minus 0.6t, because the total distance is 16. So I think that makes it a little easier to set this up. So we know from similar triangles that we have a common angle here, so that's angle, and they're both right angle triangles. They're all both right triangles, so we have angle, so we've just proved that they're similar triangles, and we know that similar triangles have sides that are proportional. So I'm going to do big over small. So the big triangle is h, that would be the height, and then this length here, this total length is 16. And then looking at the small triangle, the small right triangle here, you can see h corresponds to 2. And the base here is going to be 0.6t. So you can see that pretty readily, I think. Now we'll just solve this for h. We'll write h as a function of t here. So just cross multiply, you're going to get 32 times 0.6t. And then we'll just simplify that to 160. I'm sorry, h. Yeah. Let's redo that step. I'm not ready to write it as a function yet. Just cross multiply, you're going to get 0.6t times h is 32. So h is just 32 over 0.6t. And we can simplify that and write it as 160 over 3t. Like that. You can do that on your calculator. So now I'm ready to write it as a function of t. And it's just 160. I don't know why I put the prime there. We'll do that next step. 160 over 3t. Now we'll take the derivative, so h prime of t is just going to be negative 160 over 3t squared. So we're just using power rule here. We can write this as 160 over 3 times t to the negative 1. That's where you're getting this negative in front and t squared in the bottom. Okay, so that's how fast the height of the shadow is decreasing. The negative is important. It's consistent with the idea of the height getting smaller. Okay, so now we just want to know the length of her shadow when she's exactly 4 feet from the building. So when she's 4 feet from the 4 feet from the building, so that's 16 minus 6t squared minus 6t is equal to 4. So that's going to give me negative 6t is equal to negative 12. And t is going to be 2 seconds. So it's going to be 2 seconds from the time she leaves the spotlight to the time she is 4 meters from the building. 16 minus 0.6t, 0.6t, yips. Sorry about that, 0.6t. So negative 12 divided by 0.6 is going to be 20 seconds. I didn't think she could go that fast in 2 seconds. She could get that far in 2 seconds. It's 20 seconds. Okay, so now we just plug that in here. So this is the speed at which the shadow is decreasing. So it's going to be negative 160 over 3 times 400. And let's see what our calculator can do with that. So it's 2 over 15, negative 2 over 15 meters per second. That's how fast the shadow is. The height of the shadow is changing. Okay, so it's not that bad. The key to this is to remember your geometry. If you don't remember your geometry, this problem is going to be a bigger challenge for you. But we're using similar triangles. You'll see that similar triangles and similar shapes in general are used quite a bit in calculus. So you might want to just try to put that in the front of your brain. Just dredge it out of your geometry memory. Okay, so that's it for this problem. I'll see you again next time. Bye-bye.